Eco-polyethylene.
Across the country, initiatives have been put in place to help consumers reduce the amount of single-use plastic they use, from restaurants getting rid of straws to stores offering incentives to customers who bring reusable bags. The most common single-use plastic in use today is polyethylene that stays in the environment for centuries, threatening wildlife and spreading toxins into the Earth's atmosphere. Polyethylene is made from chemicals that come from the production of planet-warming fuels, contributing to global warming.
Plastic is one of the most persistent pollutions on Earth. Plastics like polyethylene can take up to 1,000 years to decompose in landfills. This innovation will lead to less overall discarded plastic and decrease the greenhouse gases emissions that are contributing to global warming.
If a biodegradable alternative to polyethylene can be made, then the world's overall pollution will decrease.
Polyethylene is a tough, light, flexible, synthetic resin made by polymerizing ethylene, mainly used for packaging. Over 100 million tons of polyethylene resins are being produced annually, accounting for 34% of the total plastic market. In the past, polyethylene was known for the ability to store strong acids because of its high chemical resistance.
On March 27, 1933, polyethylene was found by Eric Fawcett and Reginald Gibson, which was located at Imperial Chemical Industries in Northwich, England. It was first used during World War II as an insulator for radar cables. With the increased use of polyethylene, the pollution level caused by it has also increased, affecting almost every kind of environment, including terrestrial as well as aquatic biomes. Biodegradable refers to the ability of materials to break down and return to nature. In order for packaging products or materials to qualify as biodegradable, they must completely break down or decompose into natural elements within a short time after disposal, typically a year or less. Polyethylene takes around 450 years to decompose and up to 1,000 years in landfills. As it does, sunlight and heat cause all types of plastic to release powerful greenhouse gas emissions, leading to an alarming feedback loop. As our climate changes, the planet gets hotter, the plastic breaks down into more methane and ethylene, increasing the rate of climate change and so perpetuating the cycle. A template by Pershing was used to help create the carton for this innovation. Tapioca, glycerin, and vinegar were heated on the stove to create the eco-polyethylene.
Independent polyethylene, dependent biodegradable, controls cap opening at carton, trap a can of orange juice, box carton size.
Recipe 1. Recipe 1 was made with glycerin, water, tapioca starch, and vinegar. When done cooking, it had a slime-like consistency. This took 7 days to dry on baking tray and 1 day to dry on cardboard. It was easy to peel off the baking tray and was flexible so it didn't break.
Recipe 2. Recipe 2 is made with cornstarch, water, glycerin, and vinegar. In the end, it had a petroleum jelly-like consistency. The recipe took 4 days to completely dry and be capable of peeling off the baking tray. The solution spread onto the cardboard and dried in 1 day. When it had fully dried on the baking tray, it had cuts throughout, although the solution on the cardboard had dried smoothly without any cuts. Recipe 3. Recipe 3 was made with tapioca starch, water, oil, and vinegar. The oil had visibly risen and separated from the form of the other liquids. After cooking, it had the same consistency as recipe 1, but was slippery and covered in oil. The recipe took 1 day to completely dry on a baking tray and the cardboard. On both the baking tray and cardboard, the solution was extremely thick and clumped together, almost like a rock. It's oily and hard to the touch. The carton. The first recipe had obtained the best results for being waterproof and having a better end product than the others, so it was decided that it would be the one bioplastic used in this device. It was decided to put the plastic onto the cardboard template first rather than on a baking tray, because putting the plastic onto the cardboard first let it dry quicker. The process of making the plastic was no different than before, and it dried in the same amount of time, which was 1 day. The carton was able to hold a variety of liquids without it leaking through. From the graphs, we can see that recipe 1 and recipe 3 had a high water resistance, but recipe 3 was like a rock, so it was predictable that it would not dissolve in the water and it couldn't be used for the end product. For most of the recipes, it took a long time to dry on baking trays. From the results of this graph, we came to the conclusion that the first recipe was the best as it had low drying time, was flexible, and most importantly, waterproof. The hypothesis supports this innovation because the cardboard used as an alternative of polyethylene was a success. Due to these results, the world's overall pollution will decrease. Each of the recipes was waterproof, meaning it could last in water for more than 7 days. The 2 recipes were able to withstand water because of the glycerin they contained, while the 3rd recipe was waterproof because how hard it was. The first 2 recipes contained glycerin, making them strong and flexible, just like polyethylene. The 3rd recipe did not contain glycerin, making it hard resistant to being bent, and incomparable to the original polyethylene. Additionally, it took each recipe 1 day to dry on cardboard,
but for the majority of the other recipes, it's considerably longer to draw on a baking tray. The reasoning behind this is because the tray that the solution was laid on was nonstick. The cardboard did not contain PTFE, which makes this tray nonstick. This made it exceedingly more secure to draw rapidly on the cardboard because the solution could absorb the air better.
Anyone that buys things containing polyethylene would consider purchasing our product. With the price being near other things containing the original polyethylene, consumers will not have to feel restricted to purchasing something more expensive, letting them contribute to the reduction of plastic waste. The consumers that would be the most interested in this innovation are people that are being affected by global warming constantly, such as farmers. In conclusion, the hypothesis was proven correct. The biodegradable polyethylene has all the major characteristics that the original polyethylene has and can biodegrade within a matter of days. The most commonly used plastic is polyethylene, meaning that if this innovation were commonly used worldwide, it would decrease the amount of greenhouse gas emissions that are constantly contributing to global warming. The innovation is capable of helping the environment and the earth as it is made of organic materials and will biodegrade within a matter of days. It is known that many scientists assume that the earth will not be sustainable for humans to live on in the future because of global warming. This innovation can change that, giving the future generations a sustainable life to live.
We built this project because in our school, JWB, and received support throughout the school community.
Learning about other bioplastics and their uses around the world inspired us to create this innovation. Specifically, the 16-year-old Elif Bildin found a way to make certain type of bioplastic out of organic materials such as banana peels. While brainstorming, we found that polyethylene was the most commonly used plastic worldwide, yet it had never been made biodegradable. A difficulty that we faced while creating this innovation was figuring out how we can make the current so nothing leaked out. By doing some research, we looked for the most durable food-safe glue and used it to construct the carton, and it worked.
Our next steps, if we were to continue the project, would be to change the recipe of this plastic to fit densities of polyethylene, as our aim was to make the low-density polyethylene. Thank you for listening.